But in this model, when I have included one covariate, what I am assuming, let me tell you something more about this model. So, your wage function is wage equals to beta 0 plus beta 1 x di plus beta 2 x 1 I plus ui. This is your model, and then you have derived the interpretation in this way: expectation of wage I given d1 I equals to 1. So, d1 I equals to 1 if male and 0 otherwise. So, equals to beta 0 plus beta 1 plus beta 2 xi, and expectation of wage I given d1 I equals to 0 becomes beta 0 plus beta 2 x1 I. Okay. And we said that beta 1 equals to beta 1. How do you derive the interpretation? Beta 0 plus beta 1 minus beta 0. So, that means the differential intercept. Now, if I ask you for a unit change in education, on an average, what would be the change in male's wage? That is beta 2. Similarly, if I ask for a unit change in education, on an average, what would be the change in female's wage? That is beta 2. So, in both the cases, the incremental change in education is producing same impact on wage. So, that means if male person goes for 1 extra year of schooling, and if the female laborer goes for 1 extra years of schooling, then both of them will generate same increment in their wage. Let us say that 100 rupees or 150 rupees or 1000 rupees. Okay. So, that means what I am assuming here, that in this model, that responsiveness of mean wage with respect to education is same across gender. So, this is the assumption that we are making in this model. We have to very clearly keep this in mind. Both male and female are getting same increment when they are going for extra years of education. But suppose I am assuming a different story. When male goes for 1 extra education, let us say the increment is 100, and when female goes for 1 extra years of education, let us say that the increment is 75. That means mean wage responds differently with respect to education across gender. It is not same. Then how will you modify this equation? Okay. So, that means when the dummy variable model, we have one qualitative variable and one quantitative variable, but there is no interaction between the qualitative and the quantitative variable, This is the assumption we make implicitly. That means incremental change in your wage due to 1 extra years of education is actually same across gender. Male and female will get same increment if they go for 1 extra years of education. Now, suppose I am relaxing this assumption and I am saying that responsiveness of mean wage with respect to education is different across gender. Okay? Let us say that this assumption I am relaxing and I am saying that responsiveness of mean wage with respect to education is different across gender. This is the assumption I am making. And what should be the corresponding econometric model then with this assumption? Simply you have to interact with this dummy variable with the qualitative information. So, your model will look like wage equals to beta 0 plus beta 1 d1i or di plus beta 2 x1i plus beta 3 di and x1i should interact plus ui. So, this is going to be your model when you relax this assumption and say that mean wage responds quite differently with respect to education for male and female category. Okay. How this is so? So, now if you again what we have to do, we have already derived the interpretation of beta 1 and beta 2. Now, additionally we have to derive the interpretation of beta 3. How will you do that? So, I will do the interpretation in the next page. Okay. So, your model is now wage equals to beta 0 plus beta 1 d I plus beta 2 x 1 I plus beta 3 beta 3 d I interacting with x 1 I plus u I and d I equals to 1 if male, 0 if female. Then you derive the interpretation wage. So, that means what I will do? I will do expectation of wage given d1 di equals to 1, this would become beta 0 plus beta 1 plus beta 2 x 1 I plus beta 3 x 1 I plus sorry, this ui is not there since I have taken expectation. Okay. And this again you can write as beta 0 plus beta 1 plus beta 2 plus beta 3 x 1 I. So, this is mean wage for male category. Now, from this equation you can clearly understand one thing, that the intercept of the mean wage function for the male category is beta 0 plus beta 1, and what is the slope? Beta 2 plus beta 3. Okay? This is intercept and this is slope for the mean wage function for the male category. Now, if you derive expectation of wage given di equals to 0, what you will get? Beta 0 plus beta 2 x 1I, and this would become 0, this is also become 0. So, this is beta 0 plus beta 2 xi, this is mean wage for female category. And what is the intercept? This is the intercept and this is the slope. Okay? So, that means beta 0 is the intercept and beta 2 is slope. Okay? Now, you can easily understand one thing, that how do you derive beta 3 then? Beta 3 is basically beta 2 plus beta, beta 2 plus beta 3 minus beta 2. As I have told already, that interpretation of the coefficients in dummy variable model is always derived. So, the moment you think about what is going to be the interpretation of beta 3, you have to really derive beta 3. And how I am deriving it? It is very simple. Beta 3 equals to beta 2 plus beta 3 minus beta 2. What is beta 2 plus beta 3? That is the slope of the mean wage function for the male category, and beta 2 is actually the slope of the mean wage function for the female category. That means, if you take the difference of beta 2 plus beta 3 minus beta 2, it becomes, it tells you differential slope. Okay? Differential slope. Okay? So, that means beta 3 basically indicates the differential slope. That means, when education increases by 1 unit, male category receives increment for the male category is beta 3 unit higher than that of their female counterpart. For a unit change in education, average wage for the male category increases by beta 2 plus beta 3 unit, while for a unit change in education, the mean wage for the female category increases by only beta 2 unit. That means, there is a change by which mean wage responds towards income, towards education for the male and the female category. That is why beta 3 has now become the differential slope coefficient in this model. Is this clear? So, that means, while beta 1 indicates, and how do you derive beta 1 now? Beta 1, it is again same. See, beta 1 is nothing but beta 0 plus beta 1 minus beta 0. So, that means, this indicates differential intercept. So, this interpretation we have already derived. So, the interaction, the term, the coefficient which is attached with the interaction between the qualitative and quantitative variable actually indicates differential slope. So, when the dummy variable interacts with the covariates, the corresponding coefficient indicates differential slope, while when the dummy variable enters into the model additively without any interaction with the covariate, then we say that the coefficient attached to that dummy indicates differential intercept. Okay? Differential intercept. So, that means male categories wedge function will have intercept which is beta 1 amount higher than the female counterpart, and slope would be higher than beta 3 unit. So, if you now try to draw the diagram once again between male and female, in the x axis you have education and on the y axis you have wage, then let us say that this is your sorry, hello. Hello. Sir, good evening, sir. IFB la call pandren sir. No. So, this should become, let us say this is my wage function for the male category, where the slope is, what is the slope? Beta 2 plus beta 3, and intercept is actually beta 0 plus beta 1, beta 0 plus beta 1, and female category slope would be little. So, female categories is slope is this. So, it is only beta 2 and intercept is actually beta 0. So, female category is this, which shows lower amount of intercept and lower slope as well. So, that means for every additional unit of education, female laborers they receive less increment compared to their male counterpart. One thing you have to keep in mind, that they both of these male and female workers they will get increment. It is not that for extra education females are not getting increment, both of them are getting increment. But what I am saying here, male labor force get more increment compared to their female counterpart for every additional unit of extra education. If male laborers they get 100 rupees increment, probably the female counterparts would be getting less than 100, 80, 90, 75, whatever might be the amount. That is what I am saying. Increment is there for both, but the amount of increment is more for the male category than their female counterpart. That is why I said that in this model we assume responsiveness of mean wage is different with respect to education is different across the two categories male and female. All right. So, this is the model. So, that means how many models we have discussed today? So, we have discussed only two models, model 2 where we have both qualitative and quantitative model information. No, actually we discussed 3 models. Then in model 1 we said there is only one qualitative variable gender, there is no covariate, that is called ANOVA model. And then in model 2 we have both qualitative and quantitative. That means while DI indicates the gender, then education indicates a quantitative variable which is covariate, that is model 2, and model 3 is actually model 3 is actually this. Model 3 is this. So, that means this is our model 3, this is also our model 3. So, model 3 it basically makes interaction between the dummy and the quantitative variable or the covariate. Okay, that is model 3. So, 3 models we have discussed. Okay, this is how we have to design your variable. So, that means before estimation itself you have to formulate your dummy variable, which is very interesting and very important for empirical application. But only thing is that unlike the standard econometric model, you have to first formulate the variable, which is little involved. I will not say difficult, little involved than the standard econometric model, and after formulation of the model you have to first derive their interpretation. What is the meaning of the intercept, what is the meaning of the slope, what is the meaning of the coefficient, what you are getting by interacting the dummy with the quantitative variable. You just derive the interpretation, then you estimate the model, so that after estimation you know what exactly you have estimated. And as I said, the interpretation of the coefficients are all derived, there is no standard interpretation. So, it changes depending on what type of model you are estimating. We have also said that if you have n number of categories for a qualitative variable, then number of dummy variables should be n minus 1. That means, in our case we have assumed 2 categories male and female for the qualitative variable gender. That is why we have introduced only one dummy di, 2 minus 1 equals to 1. If you introduce 2 dummies for 2 categories, then you will have some problem, that is called dummy variable trap, that we will discuss later on. Okay? Dummy variable trap, right, when you are introducing 2 variables, 2 dummies for 2 categories. All right. So, here see, I have 2 categories male and female, that is why I have introduced one dummy. So, that means number of dummies should be n minus 1, n minus 1, where n is actually number of dummy. And if you introduce n dummy for n category, then you will have a situation which is called dummy variable trap. Okay? What is the implication of dummy variable trap? That we will discuss in a later part of our discussion. This is called dummy variable trap. Dummy variable trap. What does that mean? In dummy for n category, where the rule says actually the number of dummy should be n minus 1. With this, we are closing our discussion today. In our next class, what we will do? We will have 2 qualitative variable instead of 1, and we will see what would be the interpretation of the coefficients, and we will see what would be the interpretation of the coefficient when both the dummies they interact with each other. Here we saw the interaction between dummy and the quantitative variable, but there we will see the interpretation of the coefficient when the 2 dummies they themselves interact with each other. With this, we are closing our discussion today.